this feature is
Okay, let's get started. So this talk is about React hooks and some problems with it and how we can try to improve it. So this is a very basic example of how do we use hooks. So basically, the purpose of hooks is to remove the need of class-based components, so that we can write our functional component, but we can kind of inject some of the effects or local states, those things that we can only do with class-based component before, but now we can do it with functional components with hooks. So this is a basic example. So we have this app, which is a functional component. So inside this app, we use two hooks. The first one is use state, which we use to implement the feature of local state. Previously, we used class-based component, we create local state, but now we can use state. So the use state, you provide initial value, and then it will return two values as an array. The first one is the value of that state. The second one is a setter function, so that you can modify that state. It's the same thing here. We create another local state, and we name it surname. And another very important hook is use effect. So with use effect, we can kind of implement the feature of all the life cycle events when we use class-based components. But the mindset is a little bit different. We're not thinking about life cycle events anymore, but now we think about effects anymore. We're going to look at the difference later. So this is like the basic usage of hooks. So the good news is that we eliminate the need for class-based components, so that all our components can be functional. The benefits of using functional components is that its testability, reusability, and maintainability are better. But with hooks, the problem is that although this is a functional component, but because we introduce a lot of outside stuff, a lot of effect, so those things make this function not pure anymore. So that although hooks, the purpose of hooks is to replace class to make your program more functional, but the syntax of hooks makes it a little bit not that functional. So there's another library before hooks that will achieve almost the same purpose to eliminate the class-based component, which is called recompose. Anyone use recompose? Yeah. So this is an example of recompose. So basically, it's doing the same thing, but the difference is we are using this pattern, which is functional composition. So here, each of these functions, we call them an enhancer. So each enhancer will actually add some additional features or ability to your original component, so that we don't have to put those local states or the lifecycle events or those effects into the original functional component itself. We can extract them, those logic outside. So the benefit of this is that you can keep your original functional component pure, so that you can see that this app component is completely a pure function. So in terms of testability, reusability, and maintainability is a better way to go. So this recompose was also very popular, but the author of recompose has already stopped maintaining this library, and the author has joined the hooks team. The reason is that, yeah, the reason is with this the pattern, although it's in the structure is very good, but it has a problem. The problem is that each of these enhancer functions, they are higher order components, which means every time you use it, it's going to create a wrapper component around your original component. So here we did it 4 times, which means we create 4 additional levels of wrappers. So if you look at, let's change this to this recompose example. If we look at the, this is the Redux DevTools, or actually React DevTools. So you can see for each of these enhancer function, because each of them is a higher order component. So then our component tree become nested. So if you use a lot of those higher order components in your program, your component tree will become really, really messy. So it's hard for debugging, and it hurts performance. So that's the main reason why the author of Recompose has already stopped. And then right now, Facebook, they recommend hooks over Recompose. But we also mentioned that with hooks, it tends to keep all the logic inline inside your functional components. So it's less separation of concern, less reusability. So it's also not the best way to go. So what if we can bring the best of both worlds? So the idea is that if we can use hooks in a recompose way, that would be the best way to go, in my opinion. So that in this talk, we're going to try to create some utility functions to achieve that purpose. It's actually pretty easy to do. So we can just start creating this function. So the idea is that we want to avoid that for that we're going to have like component wrapper many times. So the idea is we still compose those functions, but instead of these functions, each of them being a higher order component, we can make them just higher order functions, which enhance the props of the original component. And in the end, when we have the fully enhanced props, then we create a final component, and then call that component with that enhanced props. So this way, we only create one extra component. So let's see how we can create such a utility function. So, oh, by the way, this presentation, there will be no slides. So there will be a lot of code demos. Export, const. We're going to create a function, we still call it compose. But this compose, we're going to follow this pattern. So this compose will take an array of enhancer functions. And all those functions, they are higher order functions that will take a prop and return additional props. So it will take an array of functions. So we can receive the functions as an array this way. This is the EXT syntax. Basically, it's the REST parameters. So basically, it will take all the remaining parameters and put them into an array. So in this case, it will be all the parameters into that function's array. And what we're going to return from that compose function is actually a higher order component, because that's the only higher order component we're going to create. So what is a higher order component? A higher order component is a function that takes a component and returns a component. So that's what we're going to do. We take a component and we return a component. So what is a component? We're talking about functional component here. So a functional component is actually a function that takes a props object and returns JSX, which is watered down, right? So it's going to take the props and then return the JSX. And how do we get the JSX? We can simply just call the original component with the enhanced props. So how do we get the enhanced props? As we mentioned before, we're going to take the original props and then set it to the first enhancer function. And then the first enhancer function will return some additional props. And then we're going to merge that additional props with the original props and then get the current props and then send it to the second enhancer function and then keep going. And then finally we get the final props. So this process sounds familiar? It's reduce, right? So we can just simply do function array dot reduce. We're going to provide the second parameter first, which is the initial accumulator. In this case, that will be the initial props. And then the callback function of the reducer will be the current result, which is the current props, and then the next function. What we want to return is the combination of the current props and the additional props that the next enhancer function returns. So we're going to return an object with everything from the current props, and then everything from when we call the next function with the current props. So that's it. That's the utility function we need. And let's see how it works. This is just basic components. So now we first import that function from our util file, which is called compose. And instead of returning the original component, we're going to return a composed version of that component. And then here we can provide an array of enhancer functions. And each enhancer function is just a higher order function that takes the current props and then returns some additional props. For example, we can return like A as additional prop. So if we do that, then our app component will receive that A as a prop, so that we can use that A inside this component and just say A equals to A. Let's see if it works. Let's change to the example. To A equals 5. It's working. So now we can put more enhancer functions, like B equals, and because every time we just merge the additional props to the current props and then send it to the next enhancer function. So the next enhancer function, when you receive the props, it already contains what's defined earlier, which in this case, it already contains A, so that we can use A here. So now, our app component will also receive B as prop. So we can use it as it's working. Okay, so that's how our new compose function is working. So let's see how we can apply this to hooks. So if we look at our hooks function use state, it returns an array of 2 items. But what we want to return from our new enhanced function is additional props, which is an object containing those properties. So we just need to create like another utility or helper function to convert the result from use state to the object. So we can create, so the naming convention from hooks is always use something, and the naming convention from recompose is always with something. So we're gonna stick with this naming convention. So with state. So with state is, if you look at the example from recompose, the with state takes 3 parameters, which is the name of the state, the name of the setter function, and the initial value. So we're gonna do the same here. So it's gonna take the name and the setter and the initial value, and then it will return a higher order function. That higher order function will take the current props and return additional props. So it will take the current props and it will return some additional props. And how do we get it? We first call hooks. So in order to call the hooks, we have to import it first. So we're going to import the use state from React, and we're going to call the use state with initial value. And then what we want to return here is an object that contains the name and setter. But because name and setter here are variables, so we have to put it into the square bracket. So name is, so the value of the state is, you remember that use state returns an array with 2 items. The first item is the value of the state, and the second parameter, the second item in that array is the setter function. So that's it. That's our helper function for use state. Now let's see how we can use it. So now we can import with state, and we can call with state exactly the same way as recompose. And now, after we call this enhancer function, our app component will receive name, set name, surname, set surname as input parameters or as props. And we can just simply copy the UI. Yep, so let's see if it's working. Yep, it's working. So basically, what we did here is we're still using hooks, but we use hook in a different way. We extract those local state and effect outside of the original functional component. So our functional component kept pure. So this is exactly what we want. And also, if we check the component tree, we just have one component. We don't have that component wrapper help. Yeah, and then, for example, for this full name, this is like a computed result value. So how do we achieve that? It's pretty easy. We just keep adding more props to our existing props, right? So we're going to create another enhanced function, and then it's going to take the existing props and then return additional prop which contains this full name, and then it will be just simply that's it. And then now after that, our original component will receive full name as a prop. Then we can just simply full name is working and it's updated. There's something I want to mention with the use of use effect. So originally we have, like before hooks, we use lifecycle events. So for example, in order to achieve this functionality, we want to set the title document to the full name. This is how we do it in reusablity, but you can imagine how we do it with the class-based component. So we have to put it into two separate events because the component did update only happens starting from the second run, and the component did mount happens after the first run. But we want this functionality to be happening after every run. So with the original lifecycle structure, we have to do this in two different places. But with hooks, we're not thinking about lifecycle events anymore. We're thinking about effects. And by default, all the effects will happen after every run. So in this case, we don't have to specify that logic into two different places. So next example is to use the use effect. So how can we do that? Again, we need to create a simple helper function. Again, the naming convention is we're going to call it with effect. So the with effect will take an effect function. So that's what we're going to take. We're going to take an effect function and then returns. It always returns the same. It will return a higher order function that will take the current props and return additional props. So the same. But because when we use effect, we're not trying to add more props to our existing props, because it's just some kind of effect, like event handler or the set interval. So we can simply just return empty object without new additional props. And inside, we're going to call the use effect. So here we just going to call use effect. And then we're going to provide, or we're going to call that function. But because when you use hooks, you relies heavily on the feature closure. For example, here we define a function, and inside this function we use the variable full name. But this full name is defined outside this function, in the outer scope, right? So this is called a closure. Whenever your inner function is trying to reference something outside that function. So this closure makes it convenient so that we can, because in the same scope, we can just use full name instead of passing the full name into this function. But there is a catch, something you have to be very careful when you use hooks because of closure. We're going to look at it later. And for now, because now we try to extract everything outside of the functional component. So we don't, when we define a effect function, we don't have access to those closures, which means we have to pass the current props to our effect function. So let's see how we can use it. So we can import with effect and call with effect with this function. But now, what we want to do is to accept the current props so that we can do document title equals to p.full name, because we don't have access to the closure, so we don't have access to the full name. But because we send in the current props, we can access through the current props. Yeah, so let's see if it's working. So you can see that the title is changed, which is correct. But if we change something, we got an error. And the error says destroy is not a function. So why this error happens? It's because when we try to create an effect, a lot of times we need to clean up the effect. For example, if we attach the event handler, we have to remove the event handler. If we set interval, we have to clear the interval. So the way you do this in the hooks is that for this effect function that you provide to the use effect hooks, the return value will be considered your cleanup function. So in this case, when you don't need to clean up, you don't have to return anything. So in this case, basically we just return whatever returned from calling the f function, right? Which is not a cleanup function. So that's why the error said the destroy is not a function. So in this case, what we want to do is that we don't want, because in this case we don't want to clean up, so we don't have to return anything. So if we do it like that, we basically return undefined, or we don't return anything. So now, yeah, the title changes. Okay, so this is the basic idea that for each hook function, we're going to create like a corresponding helper function so that we can use it with the with this functional composition style. So for the remaining of the talk, I'm not going to create those helper functions one by one. I've already created a npm package that contains all the helper functions for each of the hook functions. So instead, I'm just going to use that library, and then we're going to demo for each of the hook functions how to use it. So first, we're going to see with each example, we're going to first implement with hooks, and then we're going to implement with the library, so we can see the difference. So that library is called hookompose. So basically, hookompose. So it's exactly the same function, but with state, the second parameter, the name of the setter is always set something. So we can automatically create that. You don't have to provide it anymore. make it a little bit easier. Okay. Let's first make sure it's still working. Yeah, it's still working. Oh. So the next example I'm going to show is we're trying to create some effect so that we can display the width of the browser window on the screen. So let's first do it with hooks. So in order to do that, first we need to create a new state. Let's call it width, and set width. And the initial value will be window dot inner width. And we're going to create an effect. So inside of effect, we want to attach event handler to the window resize event. So window dot add event listener. The event will be resize, and then we're going to give it a event handler. So because we want to clean up that handler later, so let's create that handler first. So that handler will be, so every time when we resize, we want to set the width to the current window dot inner width. And we just mentioned that when we return from this effect, we can return a cleanup function. So inside this cleanup function, what we're going to do is window dot remove event listener, and it's going to be the same event and the same handler. So that's it. Let's change back to the hook demo. And yeah, let's add some UI elements to show it. So now, there is width. Yeah. So when we resize the window, we can see the changes. So this is how we do it with hooks use effect. But there's a problem. The problem is that we mentioned before that when we use effect, that effect will be run after every render. Which means after every render, we are going to remove the event handler and then attach the event handler again. So we can prove this by console log during the cleanup event. So let's just say cleanup. So now you can see that the cleanup function is called every time we resize the window, which is not what we want, because when we attach the event handler, we just need to attach it once, and then in the end, when the component unmount, we're gonna remove it, right? So we don't want to do it every time. So, like traditionally with class-based component, we're gonna attach the event handler in the component did mount, and then remove the event handler in the component will unmount. But with use effect, how do we achieve that same functionality? So with use effect function, the second parameter is actually an array, and that is called a dependency list. So what that means is that this is a list of values, So if you provide a dependent list, if any value inside that list changes, then the effect will rerun. If none of them inside the list changes, the effect will not run. And if you provide an empty array of dependent list, it means that effect will only run once, and then it will never run again. So in this case, it's actually what we want. We just want this effect to run only once, so that we already attach the event, and then we already provide our cleanup event. So when the component unmounts, hooks will help us run the cleanup function. Yeah, so let's see if it works. So this time, when we resize the window, yeah, the cleanup function is now running, which is correct. But there's in the next example, we're gonna see when you use dependency list, especially if you try to provide a empty dependency list, there's gonna be a big problem that you have to be aware of. We're gonna see it in the next example. But for now, let's try to see how we can implement this using our hookompose library. So we provide a helper function called with window event handler, and so it will help you do a lot of things. You don't have to call the add event listener or remove event listener yourself. The only thing you need to provide is the name of the event and the handler. Again, the handler, we will send the current props into the handler so that you can access the props on the current props. So in this case, we just simply want to set the width of, and then the third parameter will be the dependency list. In this case, it's empty array. So let's see if let's change to the hookompose example and something wrong here. Width not defined, of course. We first have to create this state. So which is the width state, and the initial value will be window dot inner width, and after that, our app component will receive widths as prop. So now, oh, of course. The set width, again, is because we're not using closure. We don't have access to set width. It's on the props. Yeah, so it's working. So that's how we do it with hookompose library. And if you compare, what we did here is much simpler than this. And also, we extract that logic outside the function component, which makes easier to test and easier to reuse. So a lot of benefits. Yeah, so we're gonna go ahead with the next example, which will showcase something that you need to be aware of when you use the empty dependency list. So in this example, we're going to create a counter. So yeah, we first create a counter state, and and the initial value will be 0. Again, we first look at how we can implement in hooks. And then we use effect. And this time, what we want to do is that we want to attach some event handlers on a button. So we first create this button. Create a button. Let's call it add. And then we give it ID, button 1. And then we just simply display the counter. Okay, so during the use effect, first we need to find this element. Const button 1 equals to document the get element by ID, and the name is button 1. And then the same thing, we're going to define a handler. So in this handler, what we want to do is to set the counter to be the current counter plus 1. Then we can attach the event handler. So add event listener. In this case, is the click event, and then the handler. And again, the same thing, we have to clean up. So we return a function that what we do is button 1 that remove event listener, same event and same handler. Right? So let's see it's working. Let's change it back to hooks. Then, so if we click add, yeah, works. But similar to the previous example, if we don't have a dependency list, this effect will run after every render. So, like before, we provide empty dependency list. It should work, right? Let's see. We try to add 1, and it stays at 1. It never changes. What's the problem here? The problem is because of closure. Here, inside this handler, we reference a variable that's a closure that's defined outside here, right? So if this effect function only runs once, then this counter variable, like all the closure variables, is like a snapshot. So when you first run it, it captures the value and it never changes unless you run it again. So this counter will always have the original value, which is 0. So that's why it doesn't matter how many times I click on the add button, it's always 0 plus 1 equals to 1. So that's the a feature of closure that you need to be aware of. And how do we solve this problem? Because this is a dependency list, so we can simply tell hooks that, hey, we are depend on this counter variable, right? So whenever the counter changes, you need to rerun the effect. If the counter doesn't change, you don't have to rerun the effect. Let's try to see it. We can just console that log. Just say counter. So let's depend on counter. So this time it's working, and also whenever we change the counter, the effect runs, right? So you can see it increases. But if we don't change the counter, we change something else. Like the component still renders, but the counter variable doesn't change. So you don't see it, right? So that's how dependency list works. So this is probably the biggest pitfall when you start working with hooks. So that's the first solution. We have to explicitly tell hooks that what's the values we depend on. There's another solution. Instead of depend on this counter variable, you can use a different format of the setter function. By the way, the setter function here is also a closure, right? So it's a function that's defined here. But because it's a function, its value never changes. And the use state hooks guarantees that each time when you call use state, it will return the same reference to this static function. So it's safe to use set counter inside our hook, but it's not safe to use a variable that can change. Right? So another format to update the value is to use a function. So if we do this, then the set counter will provide the newest value, the current value of the counter to our function, so that we will always get the new value. So this way, we don't have to depend on the counter. That's the second solution. There's a third solution, which is to use another hook called use reducer. If we have time, we can take a look at that example. Okay, so now let's look at how we can do the same thing with hookompose. So again, we have another helper function called with event handler. So the difference is that with window event handler, we'll work on the window element. With event handler, works on any element. So when we use this helper function, the first thing we're going to provide is a CSS selector, so that we know how to locate that element. So in this case, it will be the ID part 1, and then the second will be the name of the event, and then the third will be the handler. Again, first we have to create a new state counter, and the initial value will be 0. So here we're going to do p.set counter. The same thing, if we use p.counter plus 1, then we have to provide the dependency list of the counter. But again, in this case, because we don't have access to closure, instead of providing the counter variable itself, we just provide the name of counter. Or another option is that we can do p dot counter, yeah, whichever way you like. But if we use the other format, C plus 1, then we can safely provide empty dependency list. So if I copy the UI here,
One extra there. Yeah, you're
so here the counter will be available to our app component because we need state counter. So here, switch back. Yep, it's working. Cool. Next example is that we try to demonstrate how to use set interval. So use that. Okay, first with hooks implementation. So we can set interval with, for example, 1 second, and inside set interval, we try to set counter. Possible. And this set interval will return ID to us, so that we can later clean it up. So clear interval is that ID. And in this case, because we use this updating format, so we don't depend on anything, so we can safely provide empty dependency list. Switch back to the hooks demo. Yeah, it's working. Every second, the counter increases. So, yeah, again, we have with hookompose, we have a with interval function. So we can call it like this, with interval. First is the effect function. So in this case, it just simply repeats set. The second parameter will be the delay. 1 second. Third parameter is the dependency list. So that's it. And we switch back to hookompose. Yeah, it's working. Great. So next example is another hook function called use memo. So when do you use memo? Here, if we look at this this calculation here, this calculation happens on every render. But what if this calculation is very expensive, and we only want to recalculate if either name or surname changes, right? If something else changes and it calls the re-render, we don't want to recalculate. So the way to do it is to use the use memo hook, and then use memo hook. We provide a function to return this result. But most importantly is the second parameter, which is the dependency list. In this case, we want to depend on name and surname. Okay, we can test this again by console log something here, and then we return this. So let's log name. Okay. So if we run this, switch back to hooks command. So the full name, after first render, we calculate the full name. So it's the memo printed once. And now, if we make changes to either name or surname, it's calculated again. But if we change something else or resize, it doesn't recalculate. So that's the purpose of use memo. Yep, with hookompose. Okay. Simply we have with memo. And then the way to use with memo is very simple. With memo, this function, and then the dependency list. And here you can either do the name of these two props, or you can do p error function p.name p. So yeah, we have time for maybe another example. Yeah, the next one is another hook called useRef. So with useRef, what you can do is that you can put some mutable object into a ref. But the most popular uses for ref is to reference a UI element. Right? So with hooks, that's how we do it. We use ref, and then we can create, let's just call it input element equals to use ref. The initial value will be empty now, whatever, because we're gonna try to attach this ref to like an input element. For example, here ref equals to the input element. So after we do that, we can, for example, create another button to try to focus on that input element. So click equals to. So we have access to input element, and then we get the current value. The current value will be that UI element. So we can do focus on that UI element. So let's see. So if we focus, yeah, we focus to that input box. Yeah, so with hookompose, it's similar. We have with left, then what we can do is we call the with left, and we need to give it a name. So input element. Then that input element becomes available to our app component. So then we can do the ref here. It's will be the same. Equals to input element, and then copy the button. Okay, switch to Windows 7. Focus. Yep. Okay. I think we want to see another example? Yeah, I'll just keep going.
Ask you a question.
Yep.
That is very cool, by the way.
Cool.
Thank you for the presentation. What is your recommendation on testing in this way when you use like hooks React? All this
Yeah, that's one of the
composed
problem.
function.
That's one of the problems.
Yeah, here is difficult to test, yes, but
Yes, it's very difficult to test. Basically you cannot do unit testing. You have to do like integration testing. So you have to actually run the component
Yeah,
and
take the
test on the
snapshot.
screen. Right? But with this approach, this is just a function, right? And what it returns is JSX, which is just object. So you don't have to worry about all these props, where they're coming from. So you can do your unit testing. You just provide the value for those props, and then check whether the returned object contains like the value you expect.
yeah, that's one way. That's how to test the component. But for example, I have a like heavy business logic, like calculating the full name. This case is very simple, but for example, I have something much more complicated, like calculation. What would be your recommendation? Just extract it into the function in the same like module, and then running a test, writing a test against that, or just
I mean,
extract
if
it?
there's an effect involved, then basically you cannot do unit testing. Right? So you have to do like integration testing, test on the UI. But if it's just a full name, for example, if you don't have anything else, you just have one enhancer function, which is the reusablity full name, then you can again. So after compose, you get another component, right? So you can just call that component with the certain name, and then check whether the return JSX contains the full name.
Okay.
So you can just simply call the component like this. You can just call app with name equals to something, certain equals to something. It's just a function. Or you can give it a name here. So instead of export default, export const app1 equals to this, then you can run app1. Cool. So yeah, if you're interested, you can give it a try for the hookompose library. This contains all the helper functions for each of the hook functions. Great, thanks.